Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Seperti biasa, kita ni akan memulakan sesi pembelajaran kita ni dengan berselawat ke atas Rasulullah SAW selama 2 minit. Terlebih dahulu, kita ni membaca 3 niat penting ini. Yang pertama, kami niatkan selawat kami untuk memenuhi perintah Allah Subhanahu wa Ta'ala. Yang kedua, kami niatkan selawat kami untuk memenuhi hak Rasulullah SAW. Dan yang ketiga, kami niatkan selawat kami untuk mendapat syafaat Rasulullah SAW di akhirat kelak. Semoga dengan berselawat, Allah akan membukakan hati dan minda para pelajar untuk menerima ilmu dan memanfaatkan ilmu tersebut di masa akan datang. Disarankan kepada semua pelajar untuk membaca doa di dalam hati selama 2 minit berselawat. Doa untuk kedua orang tua, keluarga, diri sendiri dan apa saja doa yang ingin para pelajar sampaikan. Okay? 2 minutes from now.
اللهم صل على محمد وعلى آل محمد 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 اللهم صل على محمد وعلى آل محمد
Doa sebelum belajar. Bismillahirrahmanirrahim. Allahumma aftah alaina hikmataka wanshur alaina min hazaini rahmatika ya arhamar rahimin. Ya Allah, bukakanlah ke atas kami hikmat-hikmatmu dan limpahilah ke atas kami khazanah rahmatmu. Wahai yang maha pemurah lagi maha penyayang.
Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Ya Rabbku, lapangkanlah untukku dadaku dan mudahkanlah untukku urusanku dan lepaskanlah kekakuan dari lidahku, supaya mereka mengerti perkataanku.
Amin.
Amin, amin, amin. Ya Rabbal Alamin. In this session, we're going to discuss the last topic for our notes in Year 7, Topic 3.2, Probability. In this topic, it will include introduction to probability, probability scale, mutually exclusive outcomes, theoretical probability, experimental probability, finding probability in simple context. So, can you please get ready with your notes, page 148 until 167. This topic is not that difficult. You learn first, you try to understand each of the terms, and inshallah you will be survive in this topic. In this session, I will complete all the subtopics in our topic probability. So you need to highlight these key topics. Okay, first, introduction to probability. Second one, probability scale. The third one, mutually exclusive outcome. Fourth, theoretical probability and experimental probability. And last one, finding probability in simple context. Introduction of probability. Now, what is actually probability? Probability is the chance or possibility that an event we call something events as events in probability, okay, will happen. So probability is actually the possibility that something or that events will happen, okay. Probability can be expressed as fractions, decimal, or percents, but usually we express our answer by fraction. Okay, and probability must always be a number between 0 and 1. Inclusive means includes of 0 and 1. Sample space in probability means the set of all possible outcomes or elements. Okay, the set of elements. Events, as I mentioned earlier, event is something, okay. In probability, we call it events, and what is actually the definition of these events? Consists of one or more outcome, okay. It relates to the sample space. Events relates to the sample space. It has the symbol E. We calculate its probability as a fraction, although we can express probability in decimal and percentage, but most of the time we express our probability or calculate probability as a fraction. So you must recall your fraction, your basic of fraction. Okay, and here will be the vocabulary that will be used in probability when describing events. We need sometime there will be question that asks you to describe the events, okay, and these are the vocabulary that you can use to explain or to describe the events. First, certain, impossible, possible, likely, unlikely, more likely, less likely, equally likely. Okay, here are the vocabulary of probability that you need to comprehend, and you need to know how to apply in describing the events. Okay, here will be the definitions for each of the vocabulary of probability when describing events. You can refer this one, page 150 of your notes. First, certain will definitely happen. For example, the sun will rise and set every day. People will breathe air. Yes, of course it will definitely happen. Impossible will not happen. Growing wings, going to the sun, or breathing underwater. Okay, here are the examples of events that will not be happen. Okay, possible, could happen, may or may not actually happen. Visiting another country or getting a new pet. Okay, likely will probably happen. Read from a book next week. Unlikely will probably not happen, not impossible. Getting a pet tiger. Some people do have pet tiger, but it is uncommon. Okay, it is more likely that they will eat at break time than do their homework. It is less likely that they will leave school early to go to Jerudong Park. It is equally likely for a coin to land on heads or tails. So, to describe an event, you need to know these definitions and how to apply these words, okay, to describe the events. For this page 150, you can do it by yourself, okay? This example 1, we are learning to say or write a sentence with probability words, so you can use these probability words. For part A, always, sometime, never. Okay, B, sorting possible and impossible sentence. C, likely and unlikely. D, certain and impossible. Okay, so you can read these examples and add your own description, okay, for each of these words. Now, example 2, there is a bag of blue gumballs. Okay, you want to share them with your friends. They cover their eyes and pick one randomly. What are the chances that a blue gumball will be picked? Certain or impossible? The answer is certain, okay? Of course, the chances that they will take blue gumball will be certain because all of these gumballs are blue, okay? That is how you think in your exam. B, what are the chances that a red gumball will be picked? Of course, it is impossible because all of these gumballs are blue. Okay, so be careful when answering this kind of questions. Next, example 3. Which phrase from the box best describes the likelihood of each of these events? You may use each phrase more than one. Okay, so you need to choose the answers from this box. Now, part A, rolling a 9 on an ordinary 6-sided dice. Dice only have 6 sides, and now rolling a 9 should be impossible. Okay. Part B, rolling a number greater than 1 on an ordinary 6-sided dice can be happen. Okay, because a number greater than 1 will be 2, 3, 4, 5, and 6. So, your answer is likely. For part C, you take a green counter from a bag that only contains black counter. Of course, it is impossible because all of the counters are black. D, a day pick at random ending with the letter Y. Okay, you want to take Monday, you want to take Tuesday, you want to take Wednesday, you want to take Thursday, you want to take Friday, Saturday, Sunday, all of them end with the letter Y. So, certain. Okay. Last, a newborn baby being a boy. Okay. It's either boys or girls, right? Therefore, instead of likely, it will be equally likely. Same as coin, head or tail. Alright, so we're done with example 3. Next, probability scale. Probability scale, here we need the number line, okay? Probabilities are given on a scale of 0 to 1 as decimal or as fraction. Sometimes probabilities are expressed as percentage using a scale of 0% to 100%. Okay, this one is the probability scale, and actually this one you need to recall your number line. It can be the fraction strip. Okay, it really relates to this probability scale, fraction, number line. Okay, use your previous knowledge to answer the questions in this probability scale. Now, here you can see that a certain outcome is 1 or 100%, and impossible outcome is 0 or 0%. If if the events are certain, so it is of course 100%. Okay, and if the events are impossible, of course it is 0 or 0%. And when the events is equally likely outcome, it will be half. Okay, 0.5, 1 out of 2, or 50%. Okay, other than that, you need to look at the questions. You need to know the fraction of the questions and be flexible with the questions. Okay, such in this example for Lily rolls an ordinary 6-sided dice. This will be the sample set for 6-sided dice. Okay, we have 1, 2, 3, 4, 5, and 6. Now, marks with across the probability that Lily get an 8. it is clearly shown that Lily rolls an ordinary six-sided dice, so it is impossible for Lily get an 8. If it is impossible, so the probability that Lily will get an 8 will be 0. Okay? Now, for part B, mark with a cross that the probability that Lily get an even numbers. Now, P here means probability, bracket, even numbers. Probability of even numbers, as you can see here, we have 2, 4, and 6 even numbers, okay? 2, 4, and 6 are even numbers. So we have 3, right? Put it here 3, and at the bottom will be the total elements in the sample set. Okay, as you can see here, we have 6 elements, 6 values, 1, 2, 3, 4, 5, 6. So put it at your denominator. Once you simplify, you will get half, right? So it is exactly at the middle of this scale, like this. Okay. Next, example 5. Nazmi has a bag holding red, white, and green counters. Altogether, there are 6 counters in the bag. Okay. The probability scale shows the probability that a counter picked at random will be red, this one. It also shows the probability that a counter picked at random will be white, this one. And then, show on the probability scale the probability that a counter picked at random will be green. Now, if you look at the scale, this one will be the maximum. Okay, and we have 6 counter, right? When we have 6 counters, so the maximum, the denominator will be 6, and the maximum value will be 6 when we express this information in terms of fraction. So if the maximum here is 6, therefore each of this scale will be this one: 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. Okay, and then how you going to find this green? You look at red. Red is on 1, 6. Okay, 1, 6 here, and white is on 3, 6. 1, 6 plus 3, 6 will be 4, 6. Correct. So we minus with 4, 6 here. So your green will be at 2, 6. Okay, at 2, 6 here. And label your green. Okay, that is how you think in your exam. Think carefully and recall your fraction. Your fraction is really useful in this topic. Okay. Proceed with example 6. The diagram shows a probability scale, and you are given decimal values here. Okay, so please be careful. Recall your decimal for these questions. Write the letters for the probabilities of these events on the probability scale. The first one has been done for you. A, the probability of a new baby being a boy. Okay, probability of a new baby, it's either boy or girl. So it is equally likely. If it is equally likely in probability scale, we put it as half here, 0.5. Okay, for part B, the probability of picking a blue pen from a box containing 2 black pens and 8 blue pens. Total pens here will be 10, and total for blue pens will be 8. If you change it into decimal, it will give you 0.8. So your B should be here. For part C, the probability of rolling a 7 on a dice with fastest number 1 to 0. Of course, it is impossible. So C here. The probability scale will be 0 at 0. And last one, the probability of picking the letter M at random from the letters in the word game, G-A-M-E, game. So there are 4 alphabet here, 4 letters. So 1, 2, 3, 4. It will be your denominator, this one, and the letter M only 1. So 1 out of 4. When we change it into decimal, it will be 0.25. So here is 0.25. Therefore, the answer is D. Moving on with example 7. Martin has a present to wrap. He has a choice of 3 colors of wrapping paper, blue, red, or green. He has a choice of 2 colors of ribbon, yellow or green. Martin chooses the wrapping paper and the ribbon at random. Complete the table to show all the possible color combination. You may not need all the rows in the table. Okay. Now, blue is given. When the wrapping paper is blue, the ribbon can be yellow and can be green. So when the wrapping paper red, the ribbon can be yellow, and still when the wrapping paper is red, the ribbon can be green. Okay. When the wrapping paper is green, the ribbon can be yellow. When the wrapping paper green, the ribbon can be green. So please complete your notes for this one. For part B, write down the probability that the ribbon is the same color as the wrapping paper. Now, count here how many outcomes. Okay, we have 6 outcomes. 1, 2, 3, 4, 5, 6. So, what is the probability that ribbon have the same colors? This one, right? We only have one with same colors. Therefore, the probability will be 1 out of 6. Okay, 1 out of 6. Next, we move to example 8, last examples in probability scale. A fruit bowl contains apples, bananas, and oranges. The number of each type of fruit is shown in the table. Okay, so remember we only have 3 types of fruits: apple, banana, and orange. Awin takes a piece of fruit from the bowl at random. Draw an arrow to place each of the following events, EV and TS, on the probability scale. Okay, the first one has been done for you, which is E here. E, Awin takes out a banana. Now listen. For the maximum value for each probability scale, it depends on the total values in the events. Okay, in the events. Okay, like here, the total number will be 12, right? The total number will be 12. So here, when we put it in fraction, it will be 12 out of 12. Okay. Now, if it is 12 out of 12 and we try to look for this E, banana, what will be the fraction for this E? Now, banana, we have 6 banana. So 6 out of total 12. Then when we simplify, it will become half. But here we don't need simplification. We can just simply use this fraction. Okay, 6 out of 12. So here will be 6 out of 12. And then fill in the other scales. So 2 12, 4 12, at 12 and 10 12. We have done with that scale. Now move to even F. Awin takes out an orange. Orange we have 4, so 4 12. Therefore, orange will be here, F. Don't put orange or ing, no, just put the letter. Okay? And then even G, Awin does not. Be careful. Awin does not take out an apple. So that means it should be contrast of this value. Here, Awin wants that apple. Okay? 2 apples. But here in even G, Awin does not take out an apple. Okay? Therefore, it should be 10 out of 12. Okay? I repeat myself. For this value, Awin have 2 apples. But in even G, Awin does not take out an apple. Therefore, it should be 12 minus 2. That is how you got 10. Okay, so 10 out of 12 will be here. And last one, even H, Awin takes out a strawberry. Of course, it is impossible because Awin only have 3 types of fruits: apple, banana, and orange. Okay, so when it is impossible, it should be 0 here. Okay. Next, mutually exclusive outcome. Mutually exclusive means events that cannot happen at the same time. Okay, cannot happen at the same time. It is impossible for them to happen together. Okay, it is impossible for them to happen together. The probability of both events happening together is 0. Okay, so the key the keywords for this mutually exclusive: events cannot happen at the same time. It is impossible for them to happen together. Okay, remember that one. For examples, turning right and left. Of course, if we want to turn right, we will turn to right and then we turn to do the left. It is impossible for us to turning right at the same time with left, right? The second one, tossing a coin, heads and tails at the same time. No, it should be heads or tails, right? Then, for example 3, today is Monday and today is also Tuesday. Of course, it is impossible. Okay, if it is Monday, it will be Monday, and tomorrow will be Tuesday, like that. Okay, so this mutually exclusive outcome that is impossible to be the same. Okay, events that cannot happen at the same time, impossible to happen together. Now, let us try this example 9. Could the two events A and B in the following situation happen at the same time? Okay, remember in this example, we just need to know either both of these events can be happen at the same time or no. Okay, now, what A? Even A roll a dice and get a 1. Even B roll a dice and get a 6. The answer is no. For part B, even A toss a coin and get heads, B toss a coin and get tails. Of course it is no. Okay, you should get a head or a tail, like that. Okay. C, a bag contains 2 yellow balls and 3 blue balls. A ball is drawn from it. Even A, you get a yellow ball. Even B, you get a blue ball. The answer is no. D, even A roll a dice and get a 2. Even B roll a dice and get an even number. The answer is yes. Why? Because 2 is even numbers. So both of these events can be happen at the same time. Okay. For part E, one student is selected as the class monitor. Even A, Jamal is selected as the monitor. Even B, Peter is selected as a monitor. The answer is no. It is impossible to get 2 class monitors, right? So it's either Jamal or Peter, like that. So if A and B are mutually exclusive events, then probability of A or probability of B. We need to select one of them. If you want to choose both, it must be impossible. Okay, so how to write the probability for mutually exclusive events? We put like this: probability of A or probability of B. And how are we going to solve the probability for mutually exclusive events? We add. Okay, probability of A, add plus probability of B, like that. Remember, if here is OR, it shows that it is mutually exclusive events. And how to solve it? We need to add both of the probability. It is because two mutually exclusive cannot occur at the same time. They have no outcome in common. The probability that either events may happen is the sum of the probabilities of the events A and B, as mentioned earlier in this part. Okay, so this will be the calculation to find the probability for mutually exclusive events. Okay, and for this one, this is the basic for your probability of an event, and probability actually can be expressed through decimals or percentage, but most of them we solve it through fraction. Okay, and this one actually what we already cover in our probability scale in our previous slides. Okay, now the sum of the probabilities of all mutually exclusive outcome of an event is equal to 1. Okay, remember this one. The sum of the probabilities of all mutually exclusive outcome. Mutually exclusive outcome, the event should be equal to 1. Okay, I repeat myself. The sum of the probabilities of all mutually exclusive outcome must be 1. Next, example 10. Form 3C is looking for a new monitor. The probability of John becoming the monitor is 0.2 and the probability of Jenny becoming the monitor is 0.4. What is the probability of either John or Jenny becoming the monitor? As you can see here, we have this key or. If we have or here, that means this probability is mutually exclusive outcome. And how to solve this mutually exclusive outcome? We do like this. Okay. P means probability of John or Jenny. And remember, if here is or, and we need to add. This one is your probability of John, and this is the probability of Jenny. We just add them, and the answer is 0.6. That will be your final answer. Okay, so the answer is 0.6. Next, example 11. Roll a dice. Even A, roll a dice and get a 1. Even B, roll a dice and get a 4. Now, the sample set for a dice will be 1, 2, 3, 4, 5, and 6. Okay. And then, now let us answer part A. The probability that you get a 1. This one. Okay. So we have one outcome out of 6 here. Possible answer. Therefore, the answer is 1 out of 6. Okay. The probability that you get a 4. So, here, this means probability. Okay. Probability of A. And this one is probability of B. The probability of B get a 4, so this is 4. So we only have one possible outcome out of 6 possible answer here, possible outcome here. Alright, therefore the answer is 1 out of 6. Now, for part C, the probability of getting a 1 or a 4. Remember, here we have or. Okay, if or, that means this event is mutually exclusive outcome. And when it is mutually exclusive outcome, you need to add both of this probability like this. Okay, probability of A plus probability of B, and you will get 2 out of 6. If you simplify, you will get 1/3. Okay, that is how you answer this kind of questions. Example 12. Spin to win a prize. You spin the wheel which has 4 equal sectors like this. Okay, even A, you get a calendar. Even B, you get a cash coupons. Okay, so we just use the letter A here. Letter A represent calendar. You get a calendar. Letter B represent you get a cash coupon. Okay. Now, what will be the, and this P represent probability. For part A, what will be the probability of even A? So we have 4 possible outcomes here. And when you get a calendar, we only have one calendar here. So this calendar is one out of these 4 possible outcomes. Put your answer in fraction. The answer should be 1 out of 4. And B, you get a cash coupon. Cash coupon is here. So the answer is 1/4. C, the probability of getting a calendar or cash coupon. We have OR here. So if it is OR, that means this probability will be mutually exclusive outcome. So you need to add both of the probability. Okay. Probability of A plus probability of B, you will get 2 out of 4. And once you simplify, you will get half. Okay. Example 13. A bag contains 2 yellow balls, 3 green balls, 5 red balls, and 6 black balls. What is the probability of either? We have either here, either a yellow or a red ball being drawn if only one ball is drawn. If only one ball is drawn. So now, for your probability of yellow, you will have 2, and this 16, when we add all of these possible outcome. Okay, 2 add with 3 plus 5 plus 6, and you will get 16. And then we want red balls. For probability of red ball will be 5 out of 16. So if we have either or here, it indicates for mutually exclusive outcome. So you need to add both of these probability like this. Okay. P bracket yellow or red equal to 2 out of 16 plus 5 out of 16. And then you add the numerator, your answer will be 7 out of 16. Okay, we cannot simplify further, so your final answer should be 7 out of 16. Okay, please copy down the workings properly in your exam. In your notes. Okay, copy down all the solution exactly as what I put in my workings here. Okay. Moving on with example 14, the last example before we move to other subtopics. Draw a colored ball from the bag. Draw here means take out. Okay. Draw here means takes out. Draw here means take out. Take out a colored ball from the bag. Okay. There are 5 balls of different colors, orange, yellow, red, blue, and white, inside a bag. Even A, draw a white ball, taking out a white ball. Even B, draw an orange ball, taking out an orange ball. Now, how are you going to get your probability of even A drawing a white ball? So your answer is 1 out of 5. How we got 5? Here, 1, 2, 3, 4, 5. Alright, and how are we going to get probability of even B? Draw an orange ball, and the answer is 1 out of 5. The probability of getting a white OR, we have OR here. Okay, we have OR here. So if here is OR, you need to add both of these probability. Probability of A plus probability of B. Like this. Okay, this one, if we add the workings, it should be like this. P bracket A or B. Can you please add this one in your notes? This one is bracket. P bracket A or B equal to 1/5 plus 1/5 equal to 2/5. So your answer should be 2/5. Okay, remember here 2/8. Okay, for any mutually exclusive outcome probability, you need to add both of the probability. Now, discussion. In the above cases, even A and B are, as I mentioned earlier, it is mutually exclusive events. Okay, set the relationship between P bracket A, P bracket B, and P bracket A or B. Then P bracket A or B should be the additions of PA, probability of A, plus probability of B. Why? Two events cannot occur at the same time, so that they have no outcome in common. Therefore, the probability that either event may happen is the sum of probabilities of the event A and B. Okay? Don't forget to copy this down in your notes, exactly as what I share with you in these slides. Okay? No shortcut, no shortcut. And especially for this explanation, some of the exam question will ask you to explain. So just recall the definition and the concept of that topic, and use that concept and definition to answer this kind of questions. Okay. Next, theoretical probability. The theoretical probability of an event is the number of ways the event can occur, bracket favorable outcomes, divided by the number of total outcomes. Okay, so the theoretical probability is what you expect to happen, but it is not always what actually happened. You don't have to think too much about this one. This theoretical probability is actually just what we already done in our previous subtopic, in our mutually exclusive outcome, in our probability scales, in finding the probability of the events. That is actually theoretical probability. Okay, that is how you will solve theoretical probability, like your previous subtopic. This will be the formula to find theoretical probability, and you don't have to worry for remembering this formula, because this formula is actually same like the formula that we used to find out probability in previous subtopics. Okay, how we find out the probability of even A, how we find out the probability of previously we try to find out probability of banana. Okay, so same like our previous discussion. Okay, so our previous discussion is actually theoretical probability. Just remember that one. Now, example 15. A bag contains 10 red marbles, 8 blue marbles, and 2 yellow marbles. Find the theoretical probability of getting a blue marble. You circle the word theoretical probability because later on we're going to discuss about experimental probability. Okay, and remember, theoretical probability is same like how we find out the probability in previous subtopics. Alright, now we're going to get a blue marble. Blue marble, we have 8 here. Okay, we have 8 blue marble here. So the number of favorable outcome will be 8. And the total outcome, you add them all, 10 plus 8 plus 2, and it should be 20. And then P events, number of favorable outcome, number of total outcome. Here you can add P bracket blue. Okay, P bracket blue equal to 8 out of 20, and you simplify, you will get 2 out of 5. Same like how we find the probability for previous questions. Okay. Now, example 16, a spinner is divided into 8 equal sectors, number 1 through 8. Now, what is the probability of spinning and odd numbers? Odd numbers, we have 1, 3, 5, 7. So we have 4 favorable outcome out of 8. Therefore, P odd number equal to 4 out of 8. 8 is the total. When you simplify, you will get half. Therefore, your answer is half. For part B, what is the probability of spinning a number divisible by 4? Number divisible by 4 will be 4 and 8. We have two favorable outcome, right? So, the probability bracket divisible by 4, 2 out of 8. You simplify, you will get 1/4. C, what is the probability of spinning a number less than 3? Number less than 3 will be 2 and 1, correct? So we only have two favorable outcome, right? Therefore, 2 out of 8 equal to 1 out of 4, 1/4. Alright, so what actually you do in this example 16, this is what we call as theoretical probability. Okay, same like how we find out the previous, how we find out probability in previous discussion. Okay, now we're going to discuss experimental probability, the versus of theoretical probability. Okay, now experimental probability refers to the probability of an event occurring when an experiment was conducted. How to find the experimental probability? First, you conduct an experiment and record the number of times the event occurs and the number of times the activity is performed. Usually in exam questions, you are given the outcome of the experiment. Okay. Step 2, divide the two numbers to obtain the experimental probability. The formula for experimental probability of an event is number of time event occurs, and always the denominator will be the total. Now, this example 17, it mentioned that 13 out of 20 emails in your inbox are junk emails. What is the experimental probability that your next email is junk? Okay, so circle experimental probability because sometimes the question asks you about theoretical probability. So circle experimental probability. And you just look for the key information from this question. So 13 is the number of times event occurs. Okay, and total number of trials 20. We cannot simplify further, so 13 out of 20 is the final answer. This example 18 is same like the previous example in theoretical probability, but here you need to find out the experimental probability still of getting a blue marble. Okay, now here you are given the step already, and here is the result. So you just focus with the result and you look for blue. Therefore, the experimental probability of getting a blue marble, you just focus with blue. The answer is 6 out of 10. How we got 10? We add all of this. We total all of this trial. Okay. We total all of this trial. And then here you simplify further. Your answer should be 3/5. Okay. Don't worry, this experimental probability is not that difficult. You just pay attention with the key information given and solve as usual. Okay. Moving on with example 19. It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days will you expect in April? Now, step 1, you need to find out the experimental probability first of a rainy day. And this one should be here. Okay. So for step 1, we focus with the information in March. So the number of time events occur is 2, and 12 will be the denominator, like this. And then you simplify, you will get 1 out of 6. Now, step 2, to make a prediction, you need to multiply the probability of a rainy day by the number of days in April. You already have the probability of rainy day by using the informations in March, which is you got 1/6. Therefore, to predict, you need this probability and you multiply the number of days in April. In April, we have 30 days. Therefore, 1/6 times with 30 and the answer is 5. There will be 5 rainy days in April. Okay, you just follow what the information given and it should be okay. Okay. Next, comparing experimental and theoretical probabilities. Here we can compare the answers that we get from experimental probabilities and the answer that we get from the theoretical probabilities. Okay. In your notes, it is clearly explained about experimental probability and theoretical probability. Okay, experimental probability is found by repeating an experiment and observing the outcome. And usually in exam, you are given the result of the outcome. You just need to directly use the formula to find out the experimental probability. Okay, and this theoretical probability is what is expected to happen based on mathematics. And here will be the formula. I already discussed the formula in our previous slide. Okay. Now, in this example 20, a coin is flipped 20 times and it lands on head 13 times. Which is higher, the experimental or theoretical probability of flipping heads? Now, this information is useful for experimental probability. For your theoretical probability, you just need to remember a coin, you have 2 favorable outcomes, head or tails. That's it. Okay. So, step 1 here, it mentioned about find the experimental probability. So, you use this information, 13 out of 20, 20 always the total. So 13 out of 20, you will get 65%. This answer is for experimental probability. While in step 2, here we're going to find the theoretical probability of the events. Remember, theoretical probability for a coin, we only need 2 favorable outcomes. We only have 2 favorable outcomes, which is head or tails. Therefore, it's half here, which is 50%. Okay. And step 3, compare the experimental and theoretical probabilities based on the problem. Answer, the experimental probability is 65% and the theoretical probability is 50%. So the experimental probability of flipping heads is higher than the theoretical probability. You don't have to worry with this kind of questions in exam. If this question come out in exam, just focus with the basic of theoretical probability and basic of experimental probability. And if you need to explain the comparison, you just use your answers to do the comparison in your explanation. Alright? The next one, example 21. A fair 6-sided number cube is rolled 40 times. A 4 is rolled 6 times. Which is higher, the experimental or theoretical probability of rolling a 4? Now, if you are given this kind of information, this is for experimental probability. Okay, and for your theoretical probability, you just remember 6-sided number cube. A cube, we only have 6 sides, so the favorable outcomes, the total for favorable outcomes is 6. Okay, And rolling a 4, it always be 1 out of 6. Just remember that one. And repeat the same step as previous example. Find the experimental. So 6 out of 40. Like this. And since here we have percentage, we need to convert this fraction into percentage. 6 out of 40 times with 100, you will get 15%. While in your theoretical probability, before that, can you please change this one? It should be theoretical, this one. Okay, it should be theoretical. While in this theoretical probability, just remember that six-sided cube means we have 6 number of possible outcome, and rolling a 4, we only have 1 4 in a cube, so 1 out of 6. Change into percentage will give you 17%. Compare the experimental and theoretical probabilities based on the problem. The experimental probability is 15% and the theoretical probability is 17%. So, the theoretical probability of rolling a 4 is higher than the experimental probability. Okay, just like that. Next, example 22. The bar graph shows the result of rolling a number cube 50 times. What is the experimental probability of rolling an odd number? How does this compare with the theoretical probability of rolling an odd number? Now, odd number we have 1, 3, and 5, correct? 1 we have 10, 3 we have 8, this one, and 5 we have 8. So an odd number was rolled. You add them all, 10 plus 8 plus 8, you will get 26, okay? So an odd number was rolled 26 times in a total of 50 rolls. In previous steps, we already have the number of times even occurs, number of times the odd was rolled, which is 26 out of 50. You simplify, you will get 13 out of 25. And then, since here we have percentage sign, so we convert your fraction into percentage, will give you 52%. We already have the probability, the experimental probability for rolling and odd numbers, which is 52%. And now let us find out the theoretical probability of the events. Now, for odd number, we have 3 favorable outcome, right? 1, 3, and 5. And total possible outcome is 6. 1, 2, 3, 4, 5, and 6. So, for theoretical probability, odd number 3 out of 6. You simplify, become half. You change into percentage, you will get 50%. And the last step, you compare the experimental and theoretical probabilities based on the problem. The experimental probability is 52% and the theoretical probability is 50%. Therefore, the experimental and theoretical probabilities are similar. Even the experimental probability is a bit higher than your theoretical probabilities. Next, the last subtopic, finding probability in simple context. Example 23. In a class of 40 students, 8 are in the Al-Quran club and 12 are in the Bahasa Arab club. If a student is selected at random, what is the probability that the selected student is in the Al-Quran club? So, probability bracket Al-Quran, we have 8 out of 40. So the answer is 1/5. In Bahasa Arab, probability P bracket Bahasa Arab Club equal to 12 out of 40 become 3 out of 10. The next one, example 24. There are 20 counters in a bag. 2 of the counters are white. 1 of the counters is pink. 4 of the counters are black. The rest of the counters are purple. We have 20 altogether. So what will be the value for purple? Purple 20 minus 2 minus 1 minus 4 will get 13 for your purple. Okay. Now, for your example 24, you need to show that the probability that the counter is white or purple is 3 out of 4. Remember here we have OR. So if we have OR, that means this is mutually exclusive outcome. How are you going to find this probability? You need to add the probability of white and the probability of purple like this. Okay. So white we have 2 out of 20, this one 2 out of 20, and purple we have 13 out of 20. Therefore the answer is 15 out of 20. Since you need to prove the answer is 3 out of 4, so you stop this one, you try to simplify this one, and yes, we have 3 out of 4, therefore shown. Write like this, therefore shown. Next, example 25. You ask a friend to think of a number from 2 to 12. So, 2 to 12 means 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. The question is, what is the probability that his number will be 4? Number 4 is this one, right? We only have one 4 here. Probability of number will be 4 is 1. And how we get this 11? When we count these numbers, we count this number, the total will be 11. Therefore, the answer is 1 out of 11. Next, example 26. A bag contains 6 purple sticks, 2 orange sticks, and 4 black sticks, and you ask a friend to pick one without looking. What is the probability that the stick will be purple? So, total will be 12. Probability it will be purple is 6 out of 12, and the answer is half. Example 27. The probability that you randomly draw a short straw from a group of 40 straw is 3 out of 20. How many are short straw? So, you can just multiply this fraction with the total. Then you will get the number of short straw like this. Okay? And the answer is 6. Next, example 28. Firdaus has some sweets in a bag. 5 of the sweets are lemon flavored, 7 of the sweets are strawberry flavored. And when we add them, all of them, we have 12 sweets already. Okay, the rest of the sweets are mint flavored. The probability, here you are given the probability. Probability of mint flavored is 2/5. Now, since here it involves fraction, actually you can use your box diagram. Okay, to find out the mean flavored. Box diagram, how we know the total is 5? The denominator always the total. Okay, so we create 5 boxes for these 3 sweets. Okay, now 2 of these box will be the mints, and of course the rest of it will be lemon and strawberry. And previously we calculate the total for lemon and strawberry will be 12. And in box diagram, once we have the value for one box, it always be equal to the other boxes. So 12 divided by only 3, not 5, okay? Because only up to these 3 for lemon and strawberry. 12 divided by 3 will give you 4. And of course, the other boxes also have equal value, which is 4. And from here it will lead us to the final answer to find out the total sweets of mint flavor. 4 plus 4 will be 8. Therefore, the final answer will be 8. Moving on with example 29. The table shows the shoe. It should be shoe size of 23 students. A student is picked at random. For part A, work out the probability that the student has a shoe size of 8. Now, shoe size of 8 is 4, this one. To find the probability 4 out of 23. How we get this 23? We add all of A. We don't have to add, you already have this one. Okay, don't waste your time to add, you already given here 23 students. So 4 out of 23, you cannot simplify further. Therefore, your final answer is 4 out of 23. For part B, work out the probability that the student has a shoe size of 7 or smaller. We have or here. So be careful. Once we have or, so we need to add the probability of shoe size of 7 and probability of smaller. Smaller than 7, and this will be the workings. Okay, probability shoe size of 7 or smaller will be probability of shoe size of 7 plus the probability of smaller. Smaller than 7 will be 5 and 6, and the total will be 13. And 7, we have 5. So 5 out of 23 plus 13 out of 23 will give you 18 out of 23. We cannot simplify further, so this will be your final answer. Carry on with example 30. A box contains Lego blocks of the same size. Each block is white, blue, green, or red. And here will be the table. The table shows the probabilities that a block picked at random is white, blue, or red. You're given the probability for white, blue, and red. Remember, the maximum value for a probability always be 1. Okay, so to get green, work out the probability of green. 1 minus these three values. 1 minus 0.25, minus 0.45, minus 0.2, and your probability of green will be 0.1. Okay? And there are 60 red Lego blocks. How many white Lego blocks are there? Now, the total for outcomes for this question is still missing. Okay, it's still missing. See, so the first step of your part B, you need to find the total. Okay, and the complete information, only the red, probability of red, we have 60 Lego with probability of 0.2. We can use this one, red, the probability we times with the total, and your red will be 60. Remember to remove this multiply, we divide both sides by 0.2 like this. And how we got this one? Remember your basic of denominator in decimal. We move the point and make the value as whole number. Like this, we move 1 point. That is how you got 600 out of 2. And your final answer will be 300. Or you can use equivalent method like this. Probability total probability of red is 0.2 and the total is 60. And what will be the total for one hole? Okay, total for one hole. Now, to get 0.2, you need to multiply by 5. Once you multiply by 5, for this side, you need to multiply also 5 on the other side. Why we multiply by 5 here? Because we want to get the value for 1. Okay. Therefore, how to get that t? T equal to 60 times with 5, which is still you get the same answer, 300. This is your first step. Please copy down completely in your notes. After we got the total, then we can move to answer the total for white Lego blocks. Step 2, white Lego. White Lego equal to 0.25 times with 300, and you will get 75 white Lego. Moving on with example 31. The probability of full attendance girls in a class is 3/4. There are 15 girls in the class. How many students are there altogether? When we talk about altogether, that means we need the total. We need to find the total. Okay, and here the probability of girls is 3/4. There are 15 girls altogether. Now, method 1. Once you see fraction, you can first try the box diagram. Okay, because we already know that the denominator in probability always the total. So the total here is 4 boxes. Okay, 3 of it are girls, and the total is 15. 15 divided by 3, you will get 5 for each boxes. And remember, for box diagram, once you got the value for one box, it will be equal to the other boxes. So here also 5. And how we got the total altogether for these 4 boxes? Okay, these 4 boxes, 5 times with 4, which is 20. Copy this down in your notes. Or you can apply method 2. Girls, 3 out of 4 times with total will give you 15. Okay, girls, 15. And total is missing here. How to get total? Multiplicative inverse times with 15. I repeat myself. Multiplicative inverse here. Leave 4 of 3, and your answer still you will get 20. Moving on with example 32. Alex organizes a raffle for his school fight. The top prize is a ride in a hot air balloon, which will be won by 1 ticket. Altogether, Alex sells 700 raffle tickets. Miss Robinson buys 5 tickets for the raffle. Work out the probability that Miss Robinson does not win. So, probability does not win. This 700 minus with 5 out of 700. So you should get 695 divided by 700, and you simplify, you got 139 out of 140. Last one, example 33. This will be the last example for probability and the last example for our notes. Okay, after this we have completely done our notes. Alright, now example 33. At a clothing company, an inspector finds 5 defective pairs of jeans in a shipment of 200. If this trend continues, about how many pairs of jeans will be expected to be defective in a shipment of 5,000? Method 1. 5 defective find out to be defective pairs in a shipment of 200. And how many will be expected to be defective? if the shipment is 5,000. So let X to be the expect to be defective genes. Okay. If you see like this, you have equal sign here, you can use cross multiplication. You'll get 200x equal to 5 times 5,000. You'll get 200x equal to 25,000. So remove this 200 to get x. So x equal to 25,000 divided by 200. And x will be 125 pairs with defects. Okay. Or you can use method 2, your equivalent method, total and defective. When the total is 200 and we have 5 defective pairs of genes. What about 5,000 total? How many pairs of genes will be defective? And how to get this 5,000? How to get this 5,000? We multiply 20 times 25. You will get 5,000. And once you multiply here 25, you also need to multiply 25 in the other side. And how to get this x? 5 times with 25. And still you will get 125. In exam, it's up to you to use any methods as long as you get the correct answers. And copy down both of these methods. As a conclusion, here I put back the key topics that you already learned in this probability. First, introductions to probability. Second, probability scale. Third, mutually exclusive outcome. Fourth, theoretical probability and experimental probability. And last one, finding probability in simple context. This probability is not that difficult. It actually need to recall your fraction and your previous knowledge in previous topics. You just need to read the question carefully, okay, and you will be survive in this topic. Alright, and that's all for this session. Don't forget to complete your notes and complete your worksheet. This will be the last part for our notes, and after this we already complete our notes for this year. Okay, thank you so much, and assalamualaikum warahmatullahi wabarakatuh. As usual, we will end our session by reciting doa.
Doa selepas belajar. Bismillahirrahmanirrahim. Allahumma inni astaudi'uka ma 'allamtani fardudhu ilayya inda hajati ilaihi wala tansani ya rabbal alamin. Ya Allah, sesungguhnya aku menitipkan padamu ilmu-ilmu yang telah engkau ajarkan kepadaku, dan kembalikanlah kepadaku sewaktu aku memerlukannya kembali. Dan janganlah engkau lupakan aku kepada ilmu itu, wahai Tuhan yang memiliki semesta alam. Amin.